Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we were discussing about large sample test. We have already done and discussed large sample test for test of significance for single mean, difference of means, specified standard deviation and difference of standard deviations or equality of standard deviations. Also, we have done some problems in this regard, and in continuance with that large sample test for single proportion. In this session, we are going to discuss about large sample test significance for proportions. So, the objective of this session is to work out some problems in large sample test for single proportion and difference of proportions. Interval estimation is also done in this regard. First of all, 10 examples are already worked out in large sample test. Therefore, this is 11th example. A die is thrown 9,000 times and a throw of 3 or 4 is observed 3,240 times. Show that the die cannot be regarded as an unbiased one and find the limits between which the probability of a throw of 3 or 4 lies. Okay. So, a die is thrown 9,000 times means n is equal to 9,000, and out of that 3,240 times appears a success, where the success considered is appearance of 3 or 4. Okay. So, first of all we will discuss about the success. Success is considered as a throw of 3 or 4 in a die, which is equal to, when you throw a die, appearance of 3, probability is, therefore, when a die is thrown there are 6 possibilities, 1, 2, 3, 4, 5, 6. So, out of 6, appearance of 3 has got 1 chance, therefore, for appearance of 3 it is 1 by 6 and for appearance of 4 it is 1 by 6. So, 2 by 6 is equal to 1 by 3. Okay. And Q will have the usual meaning, Q is equal to 1 minus P is equal to 1 minus 1 by 3 equal to 2 by 3. Okay. So, next we have to find out the small p. Small p is nothing but capital X by n, right. Small p is equal to capital X by n, that is out of 9,000 times, how many times the success appears. X stands for the number of successes and n stands for the total number in the sample. Therefore, 9,000 times it is thrown and out of 9,000 times 3,240 times the success appears. Therefore, this is 3240 divided by 9,000. Okay. Then Q is equal to 1 minus P is equal to 1 minus 3240 by 9,000. Although this value is not required, it is computed for the clarification. Next, we will get into setting up the null hypothesis and alternative hypothesis and go ahead with the calculation and prove that the die is not an unbiased one. Okay. So, first of all, step 1 is setting up of null hypothesis H naught. Going to take the value capital P value. Capital P value is 1 by 3 in this problem, right. We have just found out capital P is equal to 1 by 3. It is the population proportion of success and the die is thrown, throw of 3 or 4 is considered. So, unbiasedly it is taken. The die is not unbiased, the unbiasedly the values are taken. Therefore, we should set up the H naught as P is equal to 1 by 3 means die is unbiased. die is unbiased, then only we can get the proper 3 or 4 appearance, and then you can fix up the value as p is equal to 1 by 3. Therefore, next step 2, H1 will be p not equal to 1 by 3, that is die is not unbiased or it is just biased. Okay. Step 3, the level of significance fixed in the question is 5% is equal to 5%. Next step 4, where the calculation part appears, z is equal to small p minus capital P divided by root of pq by n. Small p is 3240 by 9000, not simplified, we will just simplify it whole in this calculation part, minus 1 by 3 divided by root of 1 by 3 into 2 by 3 divided by n. N is 9000. Okay. After simplification, the value comes to be equal to 240 by 44.73, which is equal to 5.36. So, the calculated value is z at 5% equal to 5.36. Next we will go to the comparison and conclusion step. Comparison step is you have to compare the calculated value and the tabulated value. Tabulated z at 5% is 1.96. It is extracted from the tables shown in one of the previous session. And then now see here, the calculated value is highly greater than the tabulated value. Therefore, H naught is rejected. Therefore, H naught is rejected. H naught is rejected means the statement of H naught is not accepted, and you have to take up the H1. H1 is accepted. H naught is rejected means H1 is accepted. Therefore, our conclusion is die is not unbiased, which is the statement of H1. Okay. So, the die is not unbiased. This is what you are asked to find out. Next, we have to find out the probable limits for p. Now, since the p value is not 1 by 3, because p is equal to 1 by 3 taken in H naught is rejected. Therefore, H1 is accepted in the sense p is not equal to 1 by 3. It means we have to take up the cap values. Cap values is small p. Small p is 3240 by 9000. So, the probable limits for capital P will be, probable limits will be capital P cap plus or minus 3 into root of P cap into Q cap by n. P cap is 3240 by 9000, which is equal to 0.36, and capital Q cap is equal to 1 minus P, 1 minus 0.36 is 0.64. Substitute all these values here, small p plus or minus 3 into root of small p q by n, that is 0.36 plus or minus 3 into root of 0.36 into 0.64 by 9000. One value with plus and another value with minus. What does it gives? This is equal to 0.345. This is with subtracting the two values, and then 0.375. So, these are the probable limits for the population proportion, 0.345 and 0.375, where you decided that p is not equal to 1 by 3. 1 by 3 value is 0.333. Therefore, it is not 0.333, whereas it is lying between 0.345 and 0.375. After working out 11 examples in this topic of large sample test, next we will work out some problem in finding the sample size, right. Work sampling studies are conducted to find the utilization of a machine. Out of 200 observations made, only 40 observations indicated the machine to be idle. Find the number of observations to be made in order to satisfy 95% confidence, where you are leaving 5% for risk, to state the utilization of machine with expected accuracy of plus or minus 5%. Now, what all given in the question? First of all, 200 observations out of 200 observations. So, n is equal to 200 and only 40 observations indicated the machine to be idle. Okay. The sample proportion of idle machines. Sample proportion of idle machines is 40 divided by 200, which is equal to 0.2. Then you are asked to find the number of observations to be made in order to satisfy 95% confidence. So, 95% confidence says this is actually 1 minus alpha percentage, isn't it? 95% confidence, which implies alpha is equal to 5% and Z alpha will be equal to 1.96. So, since it says that 95% confidence, it means that H naught is accepted with 1.9 with 5% level of significance. Therefore, it is written as probability of small p minus capital P divided by root of p q by n, less than the tabulated value. This is your calculated value, right? Less than tabulated Z is equal to 95% confidence, 95% confidence. Okay. So, that is probability of this capital P stands for probability of small p minus capital P modulus is less than or equal to tabulated Z is 1 at Z at 5% is 1.96 into root of p q by n is equal to 0.95. This is one equation, and another information given in this question is to state the utilization of machine with expected accuracy of plus or minus 5%. So, the difference between sample proportion and population proportion will be less than 5% plus or minus. So, when you put it in the modulus, it becomes only 5% and that is also is 95% confidence. Therefore, you have a probability of small p minus capital P within the modulus is less than 0.05, which is 5% plus or minus 5% is equal to 0.95. Okay, this is also 95% confidence, and this equation is taken as equation 2. Now, compare equation 1 and equation 2. Equation 1 says P of P minus capital P is less than or equal to 1.96. This particular part is 1.96 into root of P q by n is equal to 0.95, whereas the second equation says the probability of P minus capital P is less than or equal to 0.05 is equal to 0.95. So, just compare the rounded parts which I have mentioned, comparing 1 and 2 and comparing the particular rounded parts in the equations. 1.96 into root of p q by n is equal to 0.05. Okay. And since p values and q values are directly not available, you have to take up a capital P is p cap value, this is equal to small p. Small p we have just found out it is 40 by 200 equal to 0.2, and similarly capital Q is taken as capital Q cap value, which is small q is equal to 1 minus p, which is 0.8. Okay. Therefore, this equation becomes 1.96 into root of p cap q cap. Actually, when the population values are not available, you can take up its estimates. that is dealt with theory of estimation. Okay. So, 1.96 into root of p cap into q cap by n is equal to 0.05. Just cross multiply 1.96 into root of 0.2 into 0.8 is equal to 0.05 into root n. N only we are finding, right. So, root n is equal to 1.96 into root of 0.16 divided by 0.05. Just square the on both sides, n is equal to 1.96 whole square into 0.16 by 0.05 whole square, and this answer comes to be equal to 245.88, and since n being the number, it should be rounded off to the nearest whole number, which is 246. So, the sample size should be equal to 246, so that you will be 95% confidence to state that utilization of the machine is within plus or minus 5%. Okay. In a large sample test, we have studied a test for single mean, test for difference of mean, and test for specified standard deviation, test for difference or equality of standard deviations, and also with respect to proportions we have seen test for single proportion. Next one in continuance with that is test for difference of two proportions. So, difference of two proportions, this formula we have to derive using the usual Z formula. Z is equal to T minus expectation of T divided by root of variance of T or standard error of T. Okay. And this is the normalization, where now the T is a parameter small p1 minus p2. Then expectation of T will be expectation of p1 minus p2 is equal to expectation of p1 minus expectation of p2. Estimated value is capital P1 minus capital P2, that is the mean of sample proportion is population proportion, this already we know. Okay. And then is capital P1 minus capital P2. Then variance of T is equal to variance of P1 minus P2, which is equal to variance of P1 plus variance of P2. Variance of P1 is P1 Q1 by N1 plus P2 Q2 by N2. Therefore, root of variance will be root of P1 Q1 by N1 plus P2 Q2 by N2. Okay. Now, we are going to deal this problem with H naught saying that P1 is equal to P2. Therefore, your Z formula will become P1 minus P2 minus expectation of P1 minus P2 we have just found out capital P1 minus P2 divided by root of P1 Q1 by N1 plus P2 Q2 by N2. And since you are going to set up H naught as P1 is equal to P2, this particular value will be equal to P and this part will become 0. Therefore, Z value will be, Z formula is small p1 minus p2 divided by root of and p1 is equal to p2 is equal to p, in the sense q1 is also equal to q2 is equal to q. Therefore, in the denominator you will have pq into 1 by n1 plus 1 by n2. Now, this is the formula for test for difference of proportions. Based on this discussion, we will do this problem. Random samples of 400 men and 600 women were asked whether they would like to have a flyover near their residence. 200 men and 325 women were in favor of the proposal. Favoring the proposal of having a flyover near the residence is considered as success. Okay. Accordingly, you have to take up the proportions. test the hypothesis that proportion of men and women in favor of the proposal are same against that they are not at 5 percentage. So, are same in the sense capital P1 is equal to capital P2. The whole population is divided into two categories, one having the flyover near the residence and another one not having the flyover near the residence with respect to one population. One population means the population of men. Similarly, with population of women, the whole thing has been divided into two classes. The women have in favor of the flyover near their residence and women not in favor of the flyover near their residence. So, after understanding the question, let us work out the problem. So, sample 1 is men and sample 2 is woman. Men in favor of flyover near the residence and woman in favor of flyover near the residence. Okay. What is given? N1 is equal to 400 and N2 is equal to 600 and N2 is equal to 600 and the sample proportion of people of men in favor of flyover near the residence is small p1. Small p1 is 200 people, right. So, out of 400 men, 200 are in favor. So, 200 divided by 400. Similarly, capital P2 is equal to how many women are in favor? 325 women. So, 325 divided by 600 and these values are 0.5 and 0.541. Next, we will step into the exact procedure for testing of significance for difference of proportions. First of all, we start up with null hypothesis H naught. H naught says capital P1 is equal to capital P2 is equal to capital P. That is, we are taking the favoritism of men and women are same with respect to having the flyover near the residence. Therefore, there is no difference in the opinions, of men and women with respect to the proposal, with respect to WRT, with respect to the proposal of flyover near their residence. Okay. So, step 2 will be H1 such that P1 is not equal to P2. So, there is difference in opinions. I just copy everything in opinions of men and women with respect to having flyover near their residence. Step 3, level of significance, if it is not mentioned, you can take it as a 5 percentage. Step 4 is calculation part, Z is equal to small p1 minus small p2 divided by root of pq into 1 by n1 plus 1 by n2, where capital P and Q values are not available. Therefore, capital P is taken as capital P cap value, which is equal to small p. Small p is equal to, the formula is n1 p1 by n1 p1 plus n2 p2 by n1 plus n2. What is n1? 200, right. n1 is 400. 400 into 0.5 N2 is 600 and P2 is 0.541 divided by 400 plus 600, and this value comes to be equal to 0.525. So, capital Q cap is equal to Q is equal to 1 minus P is 1 minus 0.525, which is equal to 0.475. So, after calculating all the values, you will calculate Z small p1 minus p2 by root of pq by 1 by n1 plus 1 by n2. The capital P and capital Q are not available, therefore, we will take its cap values. So, P1 is 0.5, P2 is 0.541 divided by root of P value is 0.525 into 0.475 into 1 by 400 plus 1 by 600, and this value comes to be equal to minus 0.041 by 0.0323, and the answer is minus 1.269. So, calculated Z at 5% is equal to modulus of minus 1.269, which is equal to 1.269. Now, coming to the conclusion part, calculated Z at 5% is 1.269. So, tabulated Z at 5% from the tables is 1.96. So, H naught is accepted because calculated value is lesser than tabulated value. The conclusion is the men and women are in favor of the flyover near their residence. Okay. Now, in this session, we were discussing about large sample test for proportions. Some problems have been worked out in large sample test for single proportion and difference of proportions. Also, the formula for test for difference of proportions is derived. The following questions may be posed. A brief large sample test for proportions. Now, for this question, you have to explain how the large sample test for proportions have been arrived, and also you have to explain the procedure, general procedure for testing the proportions, that is setting up H naught, H1 and then level of significance, and then the formula, corresponding formulas for proportions means a single proportion and difference of proportions, and how will you arrive at the conclusion. That all the general things has to be discussed with respect to the first question. And the second question is working out a problem. 20 people were attacked by a disease and only 18 survived. Will you reject the hypothesis that the survival rate if attacked by this disease is 85% in favor of the hypothesis that it is more at 5% level? Derive the formula for test of significance for difference of proportions. Thank you.